To understand the sheer scale of Jupiter, you have to picture our entire planet and then multiply it by 1,300. That is exactly how much of Earth could fit inside this massive gas giant. For decades, our understanding of this planet was surprisingly simple. Scientific models showed us a predictable, beautiful ball of gas, defined by these familiar horizontal stripes rotating in quiet harmony. In 2011, NASA launched the Juno spacecraft. Its objective was straightforward: reach Jupiter by 2016 and beam back the data required to confirm those long-held scientific models. Getting that data meant surviving an incredibly hostile environment. Jupiter generates a magnetic field 20,000 times stronger than Earth's. The radiation belts are so intense that Juno's sensitive electronics had to be sealed inside a solid titanium vault just to function. The spacecraft survived the approach and began transmitting. But the telemetry sent back to NASA sparked immediate confusion. The readings coming from the sensors looked nothing like the predictions scientists had relied on for years. The first major contradiction happened when Juno shifted its cameras away from that classic side profile and looked directly down at the planet's poles. No spacecraft had ever captured this angle before. This map visualizes what Juno found. At the North Pole, 8 distinct, massive cyclones, each the size of Earth, form a stable, geometric octagon. Scanning down to the South Pole reveals a similar anomaly: 5 massive cyclones locked into a strict 5-point pentagon formation. This defies our standard understanding of atmospheric physics. On Earth, massive storms drift, lose energy, or absorb one another. But Jupiter's geometric cyclones have been spinning for years in perfect synchronization, never colliding and never dissipating. Even the features we thought we understood turned out to be illusions. The Great Red Spot was long assumed to be a relatively flat surface storm. Juno's sensors revealed it is actually a 300-kilometer deep abyss, a towering vortex of dense gas that is currently shrinking. These permanent, geometric storms and deep vortexes suggest that Jupiter's atmosphere is anchored by powerful, hidden mechanics located deep within the planet's interior. To understand those hidden forces, scientists looked at the planetary core. The standard model of planet formation dictated that gas giants accumulate their massive atmospheres around a tight, solid, rocky center. Juno measured Jupiter's gravity field to map its interior, and the results contradicted the models again. The core is massive, 10 times the mass of Earth, but it's a fuzzy, diluted mixture of heavy elements swirling in liquid hydrogen. There is only one working theory that explains how a core gets dissolved like this. Billions of years ago, a colossal, rocky protoplanet 10 times the size of Earth locked into a catastrophic head-on collision with Jupiter. This impact physically shattered the solid core within. An impact of that magnitude means the early solar system was far from a peaceful assembly line of gradual planetary growth. Instead, our early solar system was a completely chaotic, high-speed war zone of violently colliding early worlds. This catastrophic event left the planet with its scattered, fuzzy core, a structural fingerprint of the violence that shaped our solar system. Jupiter's immense gravity field influences a complex system of 95 moons, including the most compelling candidate for life in our solar system, Europa. From the outside, Europa looks completely dead. Its exterior is a frozen shell of cracked ice, estimated to be between 15 and 25 kilometers thick. This visual compares Earth's water to Europa's. Beneath its frozen crust lies a 100-kilometer deep ocean containing twice the water of Earth. It stays liquid through tidal heating. Jupiter's immense gravity squeezes the moon, generating enough internal friction to melt the ice from within. Liquid water and an active geothermal heat source are the fundamental ingredients for biology. This frozen rock reminds us that the most toxic environments in our solar system may be the engines powering a hidden oasis for life. The immense gravity that fuels Europa's ocean also acts as Earth's primary line of defense. Jupiter functions as a massive cosmic shield, pulling in rogue comets and asteroids before they can cross into our orbital path. We saw this happen in 1994, when the massive comet Shoemaker-Levy 9 fragmented and hurtled through space. Instead of continuing toward the inner planets, Jupiter caught it, absorbing a barrage of impacts that could have triggered a mass extinction event on Earth. Astrobiologists are now prioritizing the exploration of Europa's subsurface ocean, searching for the hydrothermal vents that could sustain life far from the sun. To find out if something is swimming in that dark water, NASA is launching the Europa Clipper mission. The spacecraft will scan the moon's fractured surface and probe its ocean depths, specifically hunting for the chemical signatures that biological life leaves behind. We occupy a relatively small piece of rock in a highly volatile system, yet we have the capacity to build complex machines, launch them across hundreds of millions of miles of empty space, and peer beneath the ice of distant moons to figure out exactly how it all works.